Alrighty, well, welcome. I'm glad you made it on this cold and snowy February day. This is about as cold as it gets around here. If you're not from around here, which I guess many of you are not, I'll just let you know that we bottomed out officially. Negative 20 is Fahrenheit is about as low as we go around here. I'd like to take a minute or two and just kind of give a brief review of last week. Then we'll break up into groups and complete an activity that we were going to do at the end of last class, but we didn't get to. And then there's, of course, tons of stuff to cover today. If you read the chapter, the Kimball chapter, you probably, I don't know how you feel, like if you're confused or I'm hoping that the reason I make you read it beforehand is so that you can get a sense of what's going to happen. And then now is my chance to just clear up all your doubts and get you straight on the straight and narrow as far as how the heck to do all this. And I met with a couple of groups during the week as they were working on their group project. And the one thing I kept telling all the groups, the same thing, I kept saying, don't worry about doing this correct the first time. You don't get it correct the first time usually. It takes you a few times. And the reason it does that is because you don't, number one, you're learning as you're doing, right? If you're good at this stuff and you're just doing, a lot of times it'll take you a few iterations because you don't have the problem domain figured out yet. And we model these things based on our users' needs. We might not be an expert in accounting or marketing or purchasing, right? So we have to learn their domain before we can build them a very good dimensional model. And so it just takes time. So don't get discouraged with it. That's part of the process. I want you to understand and recognize that that's part of the process, and that's how I want you to learn. Okay, I want you to learn by failing. Do it, and it doesn't. Oh, it's not right. That's okay. That's how you get better by doing and failing. Okay, so don't freak out over that. It's not like a test where you got one shot at it and that's it. Whenever I assess you in that regard, I'm really just asking you to recall information. I'm not asking you to apply information. And in this class, whenever you apply information, we'll always have an experiential process where you can apply it incorrectly, I can get you corrected, and then you get a chance to reapply it correctly. So anyway, last week we covered requirements analysis. We learned to turn business processes into dimensional models. This was all done at the high level. And this week we will cover dimensional modeling. We will learn to design and implement dimensional models in relational databases, and we will get down to the detail level. Okay? So last week was really about the 10,000 foot view of building out your data warehouse. Now we're going to get into the nitty gritty of how to do that. And you're going to see that even in next week, we go even lower, right? So this week, we're going to go down to a 1,000 foot view. Next week, we're going to be like hovering along the ground. You're going to be writing SQL next week, right? So this week, not really any SQL. You'll see a lot of conceptual models, some logical models, tables and foreign keys with pictures of that stuff, right? I'll talk about things like there should be a foreign key here. And so if things in your head aren't really straightened out, ask me about it. I don't have the data to kind of demonstrate it. If I have an opportunity, I might poke around in the AdventureWorks data warehouse because I know they've done it in there. That's our case study to look at an implemented data warehouse. And we might just explore there and see if I can find an example of some of these things. So don't be afraid to ask questions. So here we are today in the Kimball lifecycle is dimensional modeling. We were over here in business requirements definition last week, and now we're sliding over in here. Next week we'll be in physical design, and then the week after that we'll be in details. We're sliding through this, and then we'll go down here, right? Most of it we covered. We'll discuss technical architecture and things like that as well along the way. What I love about teaching this class on a Friday is while everybody's decompressing from 3 hours of fudge, I go up to my office and I go, oh, you know what? I probably could have explained that better if I had a graphic. And so I go back to my office and immediately draw these graphics that better kind of associate or relate these concepts that I'm trying to get across to the class. So this is what I came up with. I don't know how effective it is, but I'm going to give it a shot. So this explains how you go from data warehousing, business intelligence program, all the way down to individual facts, right? And so a program has one or more projects within it, right? And so each of you are going to work on a project, each of your groups are going to work on a project in the class. And then a project contains one or more business processes. And then those business processes have one or more facts in them. What you'll learn today is that the program is in your data warehouse, enterprise data warehouse. Your projects represent several star schemas. Your business process well, each project is like a star schema. Your business process is a fact table. And then the facts are columns in the fact table that add up to something. And then that's how it relates to an implementation. And then down here, I have an example. So you have the iSchool data warehousing program. Remote lab is a project. Remote lab sessions is a business process. And the login time in minutes is a fact. Right? So that gives you an idea how it all scales down, right? And so you decide on a project, and you might work on a project a program over several years, implementing one or more projects as you go along, right? So you work on one project, you get that kind of 90% done, because they're never 100% done, unfortunately. You move on to the next project, until you get the entire data warehouse built out. And that's a Kimball approach, is to do it iteratively, one project at a time. The Inman approach is to try to build them all out, right? Don't complete these, decide on all these projects, and then implement all the projects out. Don't do one project, then go back, and then do an analysis on another project, and then do an analysis on a third project. That's not the way to suggest it. Just coming up with all the things that you want to do in your data warehouse, knowing about all the projects beforehand. That way you can have an enterprise view of your data warehouse. Whereas the Kimball approach is, let's build one project out, then let's go back and rethink about the next project from an analysis standpoint, figure out how that fits into what we already did, bring that one in, then go back and do analysis on the next one. So really their difference is when you do the analysis, not when you implement. Because you can't implement them all at once, right? It's too much work. It's too much work. All right, so here's the other idea I wanted to, the other thing in my head that I want to make a slide for. So you have requirements analysis and you have design and implementation. So the business process is the concept that I've been saying all along. That ends up being a fact table. It gets implemented as a fact table. The concept of fact gets implemented as a column in the fact table. The concept of dimension ends up being a dimension table. And even more so, it ends up being a foreign key in the fact table. Because you have to find a way to hook your dimensions up to your facts, right? A dimensional model is a star schema. So when I say dimensional model, I'm talking about the concept, but that gets implemented as a fact table and one or more dimensional tables, all hooked up. And then when I say business process, right, uses a dimension, that's a foreign key. So that kind of helps assemble how all these pieces and parts conceptually relate to all the terminology at the physical level, right, when you go to implement it. And that's important. It's important to discuss these things at the right level, right? When you're talking about a dimensional model, you're talking about a business concept, right, around a business process. We know that gets implemented as a star schema at some point. Whether or not we have that implementation or not, that doesn't matter. If we say star schema, then that means we have something, right? There's tables in some database somewhere that represent a concept of dimensional model. So that's how it all folds together. And then the last thing that we kind of covered before class was over was this idea of this tool that you can use to enumerate all of the business processes, all the dimensional models, and document with one simple picture how the entire enterprise data warehouse connects. And that tool is called the bus matrix. And what we will do today in an activity, we will build out the bus matrix. I gave you homework to decide on your business process for the project. I'll comb through each of the groups asking for that, and then I will build out a bus matrix. And the purpose of the activity is twofold. One, so you can see how to implement a bus matrix, even though the lab activity for this week shows you how to do that, right? But I also want to show you in class how to do that. I will do that with all the lab activities, by the way. I will demonstrate them all in class. We'll do them together, with me kind of driving and you kind of navigating. And then the second reason is obviously to fill out the requirements of the project. We can sit here intelligently and debate what should and shouldn't be into the bus matrix as we go through and figure it out. So that's our group activity. That's a little better. Right, so the first tab gives you instructions on how to go about doing this process. You probably already know this. It's been in the PowerPoints. We've discussed it, all right? But it's just kind of here for reference because I don't dimensional model every day. So when I, it's like, I can remember how to do that. Oh yeah, I should first identify business process, and then a fact. So the next tab here is where you actually build out the bus matrix, and it has business process. Let me zoom this in a bit. It has a business process, fact table, fact grain type, granularity, and the actual facts, and then dimensions. What you would do down here in this next tab, attributes and metrics, you're going to list out generally the facts, which fact table they belong to, and any dimension categories and which dimension table they belong to, but you're going to leave the keys out of it. Okay, these are just visible things that people might want, need, or use. Okay, it's not all the technical detail that doesn't matter to the end user. And remember, primary keys and foreign keys, end users don't care about those. Right? They don't need to see those. They're just inconsequential. And then any kind of description you might need to describe that, and then other alternate names or maybe sample values if it's not. It doesn't make sense what the value is. Offer up some samples. So we'll fill some of that out, and then over here, anything that you, as you're doing this, you might come across things that you just don't know, you have a question, need to be answered, any of that stuff you log in here. Generally, I won't log these in here. I usually have a system to do that, some kind of incident management system rather than just using the spreadsheet. But what I ask you to do as part of your process is that you put the things in that you're not aware of or your doubts that you have in here. So as I go through and I grade your work, I can at least get some insight into what you were thinking or where your thinking might have went astray, and then not penalize you for something. Well, that's related to the fact that they made an assumption about something that is, and that's why it looks this way. Rather than because there's many degrees of right and wrong here. So helping me understand your line of thinking goes a long way to assessing whether or not you're getting it. But what it's really here for is like, you're going about the process and you're like, I don't know what this column is. And this business process has this data. I don't know what this data means. So I need to find out what this data means. I have to ask somebody or have another interview. All right, let's fill it out. So did anybody in the group choose remote lab? You decide to do what is the name of your business process? Remote lab. It's okay. Don't be afraid to say something and we go, well, that's not right, or we change it because this is a learning process, right? This is tough. Okay, you're just getting it down. So, what did you decide to do? Okay, remote logins, remote lab logins. What I'm going to do is I'm going to type in remote lab logins. All right. And the fact table would be called something like remote lab login fact. You always want your tables, when you implement them, to have the word fact and dimension in them, so that when you're staring at a pile of tables in your DBMS, you know which ones are the fact tables and which ones are the dimension tables. I mean, that just makes sense, right? If you look at, for example, just in case you think Crazy Mike is the one that invented this pattern, it's false. I did not. If you look at AdventureWorks, it says DIM organization, fact call center. See that? I got to get my zooming tool on here. But all these tables in the warehouse say either fact or DIM on, so that I can easily see which ones are the dimensions, which ones are the facts. I don't have to monkey around trying to take a guess. I got to get the zooming tool on here. Okay, so I'm going to call this. Let me call this fact remote lab logins. And what kind of grain type is it? It's accumulating snapshot. Granularity. What the word granularity means is one row in this remote lab logins fact table means what? Okay? So you're simply answering a question. One row in this table means somebody logged in, or something, right? You have to know that. Okay, so I think what you're asking is that one row means somebody logged in, right? One row means someone has logged on to mobile app. I don't know if it's logged in or logged on, man. Never get a consensus on that. Logged in, logged on, you stand in line, you stand online, who knows? Right? Depends on what part of the country you're in. If you're standing in line, you're standing in line. What's a fact? Give me one of the facts. Okay, so this is great. I love this. So one of the facts is how many people have logged in. Not man. Men. All right. Can you read this? Yes. Can you read it? Good. All right. Really? Can you read it back there? You're the farthest person away, probably. All right. So, who agrees with this? Okay, so some of you don't agree with it. That's okay. That's why we're here. We all want to learn, right? So if you have some doubt about what I wrote up here, what might your doubt be? Yes?
Fact is how many people have logged in. However, fact we have written is accumulating snapshots. So how many it won't be accumulated?
Yeah, that doesn't work. That doesn't work for me either. So that if I can sum that up, the accumulating snapshot cannot measure how many people have logged in. Right? If I were to change this, let me change this to transaction or events. Right? Can that measure how many people have logged in? Yes. Now, one thing you always want to do is your fact needs to match the granularity. So one row means someone has logged in. So do I want to write 7 people have logged in into that one row? No. So you want to make sure that the fact matches the grain, right? So how do I write the fact so that it matches the grain? What would the column be for fact? Remember, fact is going to be a column. But we want that column to make sense so that the business user says, oh, I know what that means. Login, right? Or something like that, right? The fact is login. Right? And now you count the login, right? Or maybe I should say count. Login. Count. That's probably a better fact. Right? Okay, so now I have remote lab logins, fact remote lab logins is a transaction event. One row means someone has logged into remote lab, and the fact is login count. So let's think about a dimension, and let's see if our fact works. Because you do not know if this fact is going to work until you start plunking in some dimensions. So what kind of dimensions did you guys have for this particular exercise? I'm going to shrink this guy down and do a little Excel magic here. Hold on. I'm going to do a word graph. All right, so we have date. This is specifically, you want to be specific with your dates. Okay, so I want to say, what date do we care about? Login date. Have you done this before, Sandy? Okay. And then I put an X here because this dimension belongs to this business process. So far, so good? So far, so good? Okay. Login date. What's another dimension? Student. Student, right? I heard student over there, right? Student. How about login time? Do we care about time independent of date? Yes. Because you might want to do some kind of, people log in after 5 or, that kind of stuff. Right? So let's put in login time. else? Okay, so you might think student major, right? But that ends up being an attribute of the student dimension, right? So you always want to think about that. Go ahead and brainstorm all you want, but be critical of adding a dimension here that you already have. Be critical of it. Because if you can roll it up to that, there's no point in doing that. So here's how you test it. So you say, student major. So let me get a count of logins by student major. That works, right? But that's probably going to be the same as getting a count of login by student rolled up to their major, right? That's how you have to think of it. Anything else?
So with that respect, why do we even use time over here? Because just to count the logins, just date and student would suffice.
Yeah, so you might want to know who logged in on a day, but you might want to know who logged in at a particular time independent of the day. Right? So you want to break date and time independently. When you do something like orders, you probably don't want to do this because you want to know, when the water bottle was purchased at the specific date and time. You don't need to break those out. But when you're talking about this particular event, you might want to know how many people use it on Saturday or how many people use it at 9 a.m., regardless of the day.
But with that respect, why can't we use the major in that case? It could be like for some specific measure. How many logins were there from the high school or from the department or?
Because that rolls up. Like student, right, rolls up to major because it's dependent on the major, right? Now, yeah, the time of day is dependent on the dates, but we want to be able to track them independently, right? Because now you can look at it and say, all right, what about people that log in on Sundays before 9? And I can use them both as dimensions. But this is kind of like, I don't know, it's splitting hairs because honestly, if you folded it all into date time and then implemented it, it probably would work. But I recognize from my experience that you probably don't want to do that because you'll get a better model. Did you have any other dimensions?
I had a question like in terms of do we have to normalize all the dimensions so we can handle the response?
That's a great question. Is should you flatten, like if you have like a snowflaking effect where the student is related to the major, right? So I'm going to go and do it on my handy dandy pen. So the question is that if you have, now you're not going to work, huh? Oh, look at that, how about that? So I'm just going to write it out. If you have student, right? And then you have major, right? And it's one student, many majors, right? And let's suppose we have a major table and a student table. You should always flatten that into a base star schema so you have fact dimensions. You're going to learn that probably in about 30 minutes. The reason to keep it snowflaked, there's a couple reasons for that. And there's a PowerPoint slide that explains it. But the general rule is if you have something like maybe you have, and these are mentioned in entities. I would have drawn them at the crazy pen work. I don't know what happened there. I had it working earlier. I think it's because I hit that cancel button. But if you had like several one-to-manys along the way, you would generally flatten those out into one dimension. And it's okay to have all that redundant data in the dimension. That's okay. Because you want this to be easy to query. So any more dimensions? One dimension you might want to think about is the computer that they got. Right? If there's some kind of issue or problem, you might want to see, are people logging into this particular computer and always having a reboot issue or something like that? And then another thing is pool. There's something called a pool. And I know these things because I wrote the product, right? But a pool is, like we don't use it here at the iSchool, but in Maxwell, their implementation, they have like 5 computers, they only have a certain software product installed on them. And they're in one pool. And then they have like 10 computers, and they have like Adobe Photoshop on them, and they're in another pool. And then there's separate pools. And you log into a pool to use the software product you want. We keep it kind of simple here, just put everything. Keeping with this example, did anybody else pick this example? Okay, let's go with some questions.
Okay, so what about the professor as a dimension? If you want to find out the number of professors or who are the professors who are using the remote lab event, remote lab.
We have to find a way. Does the data let us do that? That's the big question, right? You guys at. Does the data let us do that? Can you get from student to professor somehow? You can, right? Right. So the question becomes, all right, one student has many professors, right? So now you have this interesting situation where you can't just put a professor in a column in the student dimension. It's a little more complicated than that, right? So we'll talk about strategies on how you address that today. But that's a good question, right? So whenever you're faced with this, right, for now, what you probably want to do is think about it, put it on an issue, but not put it up here yet, because you probably don't know how to build a dimensional model for it yet. Then later on, when you figure that out, you can add that in, right? But this ends up being a part of an issue is, why are they logging on a remote lab? Are they logging in for, Mike Fudge's class or for, Mike Doretida's class? Which class are they using? It's hard to track that because you don't know. There's no way to know that. All you know is that the student is taking both of those classes. But that doesn't mean it's not valuable either. It's just harder to track. It's harder to quantify, right? Because now you roll me up and I count twice, one for each class. That's not good, right? You want me to count once because I only log in once. So we'll talk about strategies on how to do that. Yeah, we don't have that feature yet, but that would be another dimension if we did. Like, you launched an application. But that would be a different fact rate, right? That would be a fact rate based on remote lab application launches. And then every time you opened up an application, that was an event, right? And then we could find out how many people use Photoshop on remote lab. That's the next level of remote lab, by the way. We're going to get there next. We're actually going to start tracking that in all the labs. So if you take this class a year from now, there'll be a data set, a live data set as people use stuff in the labs. Every time you query it, it'll be different because it's going to be a huge volume of data. We're going to start crossing over into the big data category when we do that because that volume of data will probably generate like 100,000 rows a week. So I'm going to have to come up with a different approach on how to collect and manage that data than the way I have now because your typical relational database management system probably not good at doing that. But again, that's my problem. But you bring up a great point, and you're thinking about this in the correct way. But it's good to recognize that if you introduce a dimension, make sure it fits in the fact frame, right? That's where professor, while it's kind of useful, won't fit in this fact frame. So if we want to do a dimensional model with professor, we make another fact that will support that. Don't try to shove it into this fact. It's okay to have multiple fact tables for the same business process or similar project. Okay, that's okay.
We need to implement the knockout time so that we can calculate the duration of one login.
Yes, okay, that's great. And that's what I want to do next. Because we're all thinking about this together, and this is fine. So if you want to track how long people have logged in, like you've logged on to remote lab for 6 hours, right? If you want to track that, that is a different fact table. Because you cannot use this fact grain to track that. This fact grain says, hey, you logged in. Right? So I need to make another one. I'm going to call this remote lab, come on, Excel, session length. And I'm going to call it fact remote lab session. I can just change it to sessions. I can't hit any function keys on this keyboard. I don't know what's going on there. It drives me insane. Because I'm a keyboard guy. It's like I can't hit F2. It doesn't work. Bad. Okay, and what kind of background would this be? So what I want to do is I want to track them when they log in, track them when they log out, record how long they were on. Accumulating snapshot. Very good. One row means someone has logged on and then gets updated when they log out. Here's my format. So, now, some of you might be freaked out Is anybody freaked out right now that it looks like the same fact? Resist the urge to try to make one fact table that does both of these things. Because you know what? It ain't going to work out. And this is all right. This is what data warehousing is all about. Making redundant data so that the reporting is easy and makes sense is okay. And so what I have is I have one business process. Hey, people are using remote lab. But now I end up breaking that out into two different fact tables. One fact table will record just the logging in. The other fact table will record the logging in and the logging out and then the time that they were on. And so what is my fact now? Let's call it session length in. You always want to specify a quantity. Session length in years, session length in hours. What is it? You know why you want to do that? So when they see a number like 7, they know what the hell it means, right? Is that 7 minutes? Is that 7 hours? Is that 7 seconds? What is it, right? So you want to specify, what would make most sense, probably minutes, right? Session length in minutes. And, we're really guessing here because it could be that most people stay on for 30 seconds, and then session length in seconds makes more sense. But I think that's a good one, right? So you see what I'm doing here? Right? Why am I saying session length, and why am I using this Campbell case and not putting spaces in there? Because eventually this is going to become what? A column in this table. And I'm just because I'm already thinking at that level, I'm not using English. I'm using create table and alter table and column in my head, right? I don't know if that's good or not, but that's just kind of how I roll. When I show this to business users, they're like, why can't you put spaces in there? And I'm like, it's just a habit. It's just a habit. Sorry. But that's okay. If you want to put spaces in there, that's fine. Just remember when you make the table, no spaces, right? It just makes it more difficult. All right, let's think about this. What dimensions do I need? Does it make sense to have login date? Here's the thing. If you're not sure, but you know the dimension works, add it anyway. Why? Why add it anyway? It's harder to add later. No harm, no foul, right? No big deal. You put it in there. It lives in there. If you add it to the queue, so what? If it's in the roll-up schema and someday it needs to be added to the queue, it's already there, right? So let's do login date. I'm going to add one over here that you didn't know, log out date. All right, who has a problem with that? Who says, hey, dates are dates. Login date, February 14th, 2015. Log out date, February 14th, 2015. What do they have in common? They're both a date. Dates are dates, right? What happens is when we implement this, we make a dimension called date. But we call this type of dimension, you probably read this is called a role play dimension. Because that dimension takes on a different role in the business process. And what will happen is in this table, there'll be two foreign keys. This foreign key is called foreign key login date. It goes to the date table. This one is called foreign key logout date. It goes to the date table. If they just so happen to be the same date, then the same foreign key value gets written. But now we have a way to join to that table twice and get a login and log out date. We need to.
I was asked about the unique key for these tables. If two persons log in at the same time, then the login date and time would be the same, right?
Yes.
So in that case, they cannot be unique.
Right.
Key for the column. So are we going to introduce a unique key right here, or?
Well, we'll get to that part. We'll get to what's the key of the fact table going to be. Don't think about that yet, because that's challenging to answer. But in essence, what your key in your fact table is the least number of foreign keys you can pick to make a primary key. You do not want to make a surrogate key in your fact table. We'll talk about why that is. Generally speaking, you find the minimum number of columns from what you made in your fact table to guarantee that you've got something unique. But using existing columns is imperative to make sure you don't accidentally write the same fact twice. You write the same fact twice, you're going to have a bad experience. If you use a surrogate key, there's a great chance that you can write the same fact twice. That's something you want to avoid. So we probably have login time, log out time as well, right? Login time, log out time. So I'm just going to add that.
About time. And just add one foreign key to the fact table.
That's what we're eventually going to do. That's exactly what a role play dimension is we're going to just have one table called time, dim time, but it's going to have two foreign keys into this fact table. One for the role of log out, one for the role of log in.
Okay, so here we are just listing the dimensions. They are not the tables.
That's right. That's right. What you need to recognize is how these translate into tables. You're guaranteed that they're going to be a table, but whether or not they're the same table, you don't know that. Well, you should know that. Experienced modelers know that, right? But again, you're at a high level. What you should not do is when you get to the detailed level, you should not make a log out date table. You should not make a dim log out date and then a dim log in date. You should not do that. You should just have dim date. And then in the notes say, this is role playing as log in and log out. Some people, like when they make their role plays, they like to do what's called a synonym. You know how to make a synonym? In the DBMS, you can take a table and give it another name. So you say create synonym dim logout date as dim date. And then now there's another table called dim logout date, but it's really just pointing to dim date. And we do this to kind of fulfill the role play, right? So that it looks like it is, but we're not copying these tables unnecessarily. Do I need any of these other dimensions, like student or login time? Do I need any of these? I probably need login time. Do I need a student? Do I need to track student in the session links? Yeah, you probably want to know who logged in, right? Computer. Yeah. Pool. What's interesting is I'm going to take pool out because the pool, one computer, is in one pool. So there's a relationship between computer and pool. So pool actually collapses into computer. If I pick on any computer, I can roll up to the pool. Okay, so that looks good. So there's actually one more business process in here, and I'm going to just type this in here. And then, what am I thinking? Can you guess what I'm thinking? What's that? Yeah. So I need a periodic snapshot that says right now how many people are logged in. How many people are using it right now? 14. Right? I need something like that, right? So I need a periodic snapshot. This is difficult because you have to choose a grain, like every minute or every hour or every 5 minutes or every second, right? And you have to be very careful about this because if you say, I'm going to do it every second, and let's suppose you have 100 Road Lab computers, right? You are going to record maybe 100 facts every second. Right? If there's 17 people logged in, you just logged 17 facts. Or did you? I don't know. Maybe. I don't know. Let's look at fact ranking. So this is remote lab usage. How's that? I'm very good at naming things, but you get better at these as you go along. Fact, remote lab usage. One of the things that you should do is you want these to match what the user understands, not what makes sense to you, right? So, when I talk to James Powell, who runs a lab, he goes, I need to know usage of remote lab. I'm like, that's the word used. So that's the word I want to use. Because I'm building this for him, I'm not building it for me. And then what's the granularity going to be? It's going to be one row at a point in time for number of students using. Now I can implement this a couple of ways. I can decide, do I, at that point in time, record a fact for everybody who's logged in? Or I can, at that point in time, count how many people are logged in and just record that fact. I can, at a specific point in time, say, hey, there's 17 people logged in, and I can write 17 rows to the fact table, one for each person logging in. Right? Or I can, at a point in time, just say, hey, there's 17 people logged in, and just write the number 17. Which one's better? I don't know, but the fact grain and the dimensions you use will change based on the fact grain. So let's try it both ways, okay? And see where we go. Because this is really a learning exercise. So let's suppose it's one row at a point in time for the number of students using Remote Lab. That means at that point in time, if there's 17 people using it, I'm just going to write 17. Let's figure out which dimensions work. Okay, so I'm going to have something called login count. That's another fact, right? It looks similar to that fact. It doesn't matter. It's in a different usage, right? Or maybe I want to call it usage count, right? So we don't have, disambiguate it. Can I use the date that they logged in? Can I use that? Be careful. No, I can't use the login date. I can use date. What's the date that I took the snapshot, right? So I have another dimension here called date. So put an X there. Is it going to ultimately is it going to be the same date dimension? Yes, right? But it is not. It's not that role. Right? I don't want to call it that. What about student? Can I use student? No, I don't get that dimension anymore. Uh-oh. I don't know if I like this model. Right? So I can't use this dimension. Can I use the time dimension? Yeah, I can use the time. And this is one where you might argue that date and time makes sense now. Because if you cluster date and time together, now you're saying at this particular point in time, this many people log in. At this particular point in time, this many people log in. So you might consider this like date and time together. Or you could make date and time like this. It doesn't matter. Either one. Either one's fine. What about computer? Can I use computer? No. Man, I just lost like a whole bunch of dimensions. Okay, let's ask ourselves a question. Do we care? Don't answer that. Don't answer that. Because this is ultimately the point of the exercise, is I want you to understand the implications of the process that you're following, right? And I thought this would be a great example. I could have picked anybody else's example, we could have done it. But this works just as fine as any of them. So call this back remote lab usage detail. I want you to watch what happens here and let me know when you recognize what I'm doing. One row at a point in time for the number of students using remote lab. Record each individual student. Nice. And I'm still going to have usage. But I'm not going to have it's not going to, it's usage count, but now it's a different grain, right? Hey, right now, I'm logged into Remote Lab. I get a 1. Hey, right now, you're logged into Remote Lab. You get a 1. If I add it up, that's 2, right? The fact that I write here is 2. The fact that I write here is 2 rows with 1s in it. And now, all of a sudden, I get, and I'm just going to do it, I get this, and I get these. Because I'm writing out the student. I actually get login date, too. I get this. I get that, and I get login time. I don't get log out, but I will get log in date. Right? So what's better, row 5 or row 6? It depends, right? You might need them both. You're like, oh my God, wait, we just took one simple business process and we have 4 fact tables. This is what happens. You cannot make one fact table that works for everything. It's not going to happen, folks, because it all depends on the level of detail that you're trying to capture. Okay? It's okay to capture things at a higher level, but the higher the level you capture things at, the less dimensions you're going to have to use. But somehow, that should be okay. Right? And one dimension that we can include in here that we could not include at the other level is pool. So what I can do is I can capture at this level 43 people have logged into the iSchool pool. 17 people have logged into the Whitman pool. I can do that. This level captures the individual computers which belong to the pool. Right? So now I have a dimension that is actually part of another dimension. Right? Okay, there's actually a PowerPoint slide on that. So this actually worked out better than I thought, because this will kind of help cement in some of these things you're going to see. So does this one work or does that one work? That's not a question that you need to answer. The real question you need to answer is, do you need both levels of granularity? You only know that if you ask a business. Right? You want to build some cool dashboard that shows logins over time, like some kind of like trending graph in real time, then you need this dimensional model. Could you use this dimensional model to do it? Yes. Right? But this one would probably perform better than that one, because this one has the actual number, and this one you have to count the computers. How does row 6 differ than row 3? I'm surprised someone hasn't barked in and said, aren't those the same thing? What is different about row 3? Well, you can't see the row numbers. What's different about the top fact table and the bottom fact table? How are they different? Yes, it has to do on when the facts are collected, right? The top one, the fact is collected as it occurs. The bottom one, the fact is collected at an interval. They're different. See that? They're different. If I were going to do this, I would probably at least have 1, 2, and 3. This one, there's not enough volume in Remote Lab where I can't on the fly calculate. Right now there's 17 people logged in Remote Lab. Okay. But there are situations where you do want to have this grain of fact, because it's a summary level, it's a higher level, and it's very useful for dashboards, right? Where somebody wants to see things at a very high level, second level. Did this help? Does this kind of help you figure out how it all comes into play, right? You have to really think about your process, the type of grain, write out what each row means, come up with what you want to quantify. Usually there's at least one, but there's probably more than one in usual cases. And then figure out the dimensions. Remember, whenever you pick a dimension, say, how does that dimension work for that grain that I picked? Because you should be able to recognize that, for example, in this grain, I can't use student because I don't have it. I didn't capture student. I just captured, right now there's 17 people logged in. Rate it. Right now there's 18 people logged in. Rate it. I have no idea who those people are. I didn't record that. And that's an operational decision that you make when you're designing. I'm going to save this and distribute it to all of you so that you have it. Okay, I'll save it, put it up in Canvas. Ultimately, what I'd like us all to do is, as you build out yours, we'll all combine it into one big sheet so that they're all there, and you can see what a dumpster fire this is when you have like several business processes. It's huge. I mean, there's probably going to be 50, 60 rows for one for each, right? But this is what building a data warehouse is all about, right? But each of these, think about it. If I try to combine all these into one, it would be very confusing for the end user to use it. Right? This is very simple. If you want to track logins, you open up that one. If you want to track how long people are logged in, you open up that one. If you want to track, how many people are using it at a point in time, you open up that one. It's very simple. Okay? Keep it easy like that. It's okay.
From the computer dimension, can you not roll up to the pool?
Yes, you can, but not in this case because we're not capturing the computer dimension here.
So why are we not capturing a computer dimension there?
Because this periodic snapshot is writing the number of people currently logged in at a time interval. So it's saying right now there's 24 people logged in. I don't know who they are or what computer they're on. I'm just counting.
So I don't need the pool also in that case.
You do need the pool, so you can roll that up to the pool level because the counts can be made at the pool level. You can say in this pool there's 17 people, in this pool there's 4 people. I just chose to do that. I could have chose not to, but again, the more dimensions the better. Right? The more dimensions the better. That's why I like this option because it has more dimensions than this option. But I also recognize that this probably has a use somewhere.
The remote lab usage. It says the date, time, and pool. Should it have another column that talks about the count? At that
Where am I looking? Right here?
Yes.
Or here?
above.
This one?
Yes.
And I have usage count. Should I have another fact?
Another attribute.
Okay.
Dimension that says the count.
It saves the count.
Says the count.
Oh, says with the count.
Number of people logged in.
Oh, that's gonna be here. That's gonna be written here as a fact. Right? Because you got to think about what happens here. If you take a particular date and then time, you'll know that there's 24 people on it. That's the fact here.
You said third and sixth row is similar. Could you please explain that again?
What's that?
The third and sixth row, you said it's similar.
Okay, yeah. So the top row and the bottom row are very similar. The only difference is how we're collecting the data, right? In this top row, we're collecting that data as it happens. This is a transaction fact. So you log in, we record that fact, right? The bottom row, we're collecting it on a time interval. So what we're doing is we're saying, right now, let's go through and see everybody who's logged in and record each person that's logged in as a fact. And then 5 minutes from now, let's do the same thing. So they record at a different level, and that's the true definition of periodic snapshot and transaction event. Transaction event, you're recording the facts as they occur. Periodic snapshot, you're looking at how the data looks at a point in time and then recording several facts at that time. Okay? And they serve different purposes. You cannot answer the question, how many people are logged in right now with the top fact table. It won't do that. There's no easy way to do that. If you try to make this fact table do that, you will end up writing one of those nutty queries that I showed you in the beginning of class, those crazy queries with all these group bys and havocs and sub-selects. That's what ends up happening. And when you start to do that, you're going against the concept of dimensional modeling, which is to make one fact table and a bunch of dimensional tables, and the only query you have to write just joins the dimensions of the fact table. It's a pretty simple, flat query. If you break out of that, you need to recognize that you probably picked the wrong grain for the business process, and then redo it. And that's why I've been telling all the groups, you're not going to get it right in the first try, but you need to be able to recognize when it's wrong. And the way you recognize when it's wrong is when you can't write the query that solves the question. Then you know that you did something wrong, and you need to rethink your grade. You need to rethink your fact.
Why would a business user prefer transaction over periodic snapshot?
I think it's just a matter of how you want to count the same thing, right? So transaction lets you count what has happened, right? And the periodic snapshot lets you summarize how something looks at a point in time, right? So they do different things, right? So it's very common for one business process to have 3 different fact grades, depending on how you want to capture that same business process. For example, if it's orders, I might want to have a transaction event when you pay for the order, so that I know how much money we took from you, right? Then I might want to have a periodic snapshot that tells me how long you go from order to shipping, right? Then I might want to have accumulating snapshot. Then I might want to have a periodic snapshot that maybe shows at a given point in time how many orders do we process, right? Or how many orders are in a pending phase at a point in time. And then maybe you'll do that daily. You say, like, at the end of the day, end of business day, how many orders do we still have outstanding that we have to process? And that might be a periodic snapshot. So again, you got to recognize that one business process could have several different fact tables to suit different needs, and that's why they all exist. It's very seldom the case that one business process has just the periodic snapshot, and that's it. There's usually several ways to slice them in half, and that's pretty common.
I'd like to go back to the remote lab sessions on a bit.
Yeah.
What if I want to know how many students got logged out because of inactive sessions? Should I be worried about that one?
Okay, so you want to know how many students got logged off
Because
due to inactive sessions, right? So that might be a different fact table. You might need a different fact table for that, and that would be an event, right? So we would just count log-offs due to inactive, right? So I would have another fact called remote lab log-off due to inactivity, and then bam, another row. See, that's a great example of the fact table can only count specific things, and you can't make that one fact table count 8 other things. It just is not going to work for you. You need to capture different events differently so that you have them adequately. What you can do is reuse all the dimensions. And that's the awesome part. You can reuse the dimensions. Fact tables, very hard to do that. So what I recommend doing is make more fact tables than make a fact table for everything. Then as you implement the fact table, you might go back and say, you know what, I can combine this fact table and that fact table together and simplify it. But do that after you design them, because that way you're not confusing yourself over the business processes, right? So I always err on the side of making more of these, and then when I actually start to implement them, I'm like, this one looks exactly like the other one. I can just make one fact table that does both, and then make a view, or a synonym on the fact table, so that the end user sees 2 different fact tables, even though it's the same one. Right? I like to make a view in that case because then I would hide this column and show that column in one view, show this column and hide that column in the other view, and then magically the end user just sees what they want and what they need, even though I've implemented it all in one table. But that's a great point. Is that sometimes you just can't. Sometimes you can combine these things, but don't try to think about that right away.